Hello YouTube vintage stereo collectors and restorers. So here's part 4 of the KA-2000. The other parts we kind of moved backwards from the outputs. The speaker coupling caps, whose role is to keep DC voltage off the speakers and allow AC to pass. We did those underneath. Today we're going to talk about these little potentiometers on the board, main board here. These two are bias. Those transistors, those transistors. Bias is basically slightly turning on the outputs and their drivers so that they're at their optimum operating point. It's really important. If you have no bias, it'll still play music, but it'll be a little bit off. Transistors work best when they're just slightly warm, slightly on. And then you run into an interesting little problem with these amps. There's a PNP germanium transistor, and you'll see this, I've seen this design in Pioneers and Sansui of the same era, and then an NPN. And they're paired and work together as a push-pull. And they drive the two NPN outputs. It's called a Suzuki pair. That was the inventor. Probably not pronouncing it right. Japanese inventor. So what you need to do is to bias them on and set the center voltage. And that's basically how much does this one work and how much does this one work. And then over here is the protection circuit. It detects clipping. And when it clips, it turns down the preamp stage. I used to just do this. I'd go and I'd give those pots a little bit of neutral and let them soak and then turn them and adjust them because they were always off. Think about this. You have a lid on top, but there's grill slats for heat. This is right underneath it. And there it is with all the dirt landing on it and not touched for 50 years. I've seen beautiful restorations that have a fatal flaw. They haven't changed those pots. And there's something much better available. I mean, they worked with what they had. These small sealed pots, they're made by Burn. And you can buy them at like almost any of the electronics wholesalers. So you got to match them up with a couple changes. The plan is to eliminate the germanium transistor. Everything else in the amp is silicon. This is just an engineering foible of the time. PNP transistors were germanium because that's the germanium world of the 50s and 60s. NPN transistors were silicon. They need to match. So the setting that matches those two together so that they drive this equally is different if you have two NPNs. And this is through trial and error. I've come to use these. 2N2219, which is a metal case, it's a metal case version of a 2N2222. It has about 0.8 amp power handling. It's more than enough to drive, so it will replace the NPN. And then the complementary, well, the pair to it, the PNP pair, is a 2N2905A. And I recommend metal case transistors in the drivers because there are no heat sinks for them. The plastic versions, I've had issues when pushing the amp. They will eventually blow early. They can't get rid of heat. And a lot of times with this design, and this is what makes this design sound so good, when you're listening at low levels, you know, in the evening and trying to relax, it's these two little transistors that are doing the work. The outputs are not likely even turned on, so it functions as a class A amp at low volumes. There's a turnover point where these outputs come on and start doing the work. That needs to be imperceptible for the amp to work well. So these are a great match for that. And to prepare for using a silicon pair in place of the Suzuki pair, there's a couple things you need to do. So the 500 ohm bias pot here needs to be a 1K. And I'll get back to why I sprayed those, even though I'm not going to turn them. The center voltage pot, which is a 30K in the original design, sometimes I've seen 20Ks there, needs to be a 50K. And there's a reason. I wanted to eliminate that transistor, and I figured out a way to do it through trial and error a while ago. You need a little more range on these controls. There's nothing else to change. There aren't any other resistors to change or caps. You need to be able to adjust that just slightly out of range from where it is. And then these protection pots, you can leave them in. They're probably okay. That needs a 10K to replace that one. Then you end up with nice sealed precision pots. And this is the one thing here. If you leave these in and you have a meter hooked up to it, they drift. Even if you just put your finger on it, they will drift just from the warmth and movement of your finger. And here's why I sprayed it. I figured something out by accident. I was working on, I believe it was a Sansui 2900 or something. The pots where it had 2 bias pots. And I thought, well, I don't have anything to replace them with. I'll try to save them. I sprayed it. And then as I go along, I clean up the board with a Q-tip. So when I work on this area, a Q-tip, I get all the dirt off it, what I can't blow off. And I figured out, whatever's in this stuff, it loosens the dirt. Makes it very easy to clean up. So if you have a little bit of neutral, lighter fluid does the same thing. It creeps on the board, soaks in the dust, and makes it come off like nothing. Which is kind of nice. Like, then you end up with a nice new looking board. And it doesn't harm the board. It's designed not to harm plastics, phenolic resin, any of that stuff. If you don't, you end up having to work it a lot harder. And we're going to be replacing a lot of stuff on this board. It is quite a bit of work to get these out sometimes. They actually fall apart as you get them out. You'll unsolder it from the bottom. I'll just show you the bottom. Just before we run out of time on the video, I like to keep them under 10 minutes. Okay, so right there, they're in this area, the 4 corners in the center. Sometimes to get them out they fall apart, and then you realize what a bad, how they haven't really stood up. So this is the best upgrade you can do the whole time, even if you leave in the rest of the original transistors. To do what we've done this far is amazing, but we're going to go right through the whole thing. Thanks for watching and listening.